Hey everybody, it's Mr. Mott. I want to go through your Barker Lake lab report and how you can turn in an awesome first lab report in Honors Chem. So here we go. So wherever we have it, right now we've got all of our resources in the Schoology page for Honors Chem. So if you go and scroll all the way down, you got a folder called Lab Report Resources. And we click on that, and what I'm going to use is the OLR, Organizing a Lab and Lab Report. And more specific templates that we have are here, but I find that sometimes I get lost in all the different details that are on there that don't necessarily apply to us, and that kind of leads to some confusion. So I'm going to use this, so when I click on this, it's going to open up our OLR in a PDF, which I already have open. And so what I'm going to look at now, first of all, is first thing we need to do is put a title in here. Now, this particular lab doesn't have a true independent variable, so it makes the first part of our lab report a little bit tricky. But basically, you want to talk about how dissolved oxygen is going to impact whether or not your fish, whichever your class decided, will be able to survive. And so your title is going to be something about the survival of your fish in Barker Lake, related to the things that we measured, which was dissolved oxygen. Okay. Once you have that, basically what we'll do is it will take in your problem statement, what you're going to do is kind of reform that into a question. Okay. So can your fish survive in Barker Lake based on what we measured, our dissolved oxygen levels? Okay, so something like that. So reform, take your title, however you kind of phrase it, and it's got to rephrase that in terms of a question. Okay, your problem statement is going to lead us into our objectives. Okay, so something I should mention, by the way, as well, is that your title page is going to be a separate page. Don't worry about that. We're turning it electronically. So it's going to be a separate page. A lot of people try to put a picture in there, which is great. Okay, when we start doing the rest of this here, this is not jammed together in one big paragraph. These are kind of separate little, you can make them like bullet points, things like that, little subheadings. That will be great. All right, so we mentioned your problem statement is basically your title rephrased in terms of a question. So what you want to think about is what would you need to be able to what information would you need to be able to decide whether or not your fish can survive in Barker Lake? So first of all, you want to think about, well, what do we measure? We measured dissolved oxygen levels. How did you physically do that? Did you put a electronic probe in the water? Did you? The answer to that is obviously no. We use our Hawk test kits, and so in order to be able to do our lab, you had to be able to use the Hawk test kits. So you had to learn how to do that. You had to actually physically go collect the data. And once we had the data, we compiled that into a data table and we had to analyze it. Okay. So within that, you could maybe also think about, we had to understand accuracy versus precision. That's why we did that kind of bullseye activity during class. So I would say those are our three main objectives. So again, your objectives are, how are we going to solve this problem? What would you need to be able to do? And then we also, so the Hawk test kits, compiling the data, analyzing the data, and also doing background information. So maybe there's about 3 or 4. Okay. So then we start listing our background information. Our background information should include background on your fish, should include background information on Barker Lake, and Salt Creek. So things that you should consider are, the needs of your fish compared to the needs of Barker Lake. Like, those are going to be really core things to find out. And remember, if you're grabbing information from a specific site, make sure to reference that. Okay, you can just add a link right after it within your lab report. If you want to add some footnotes in there, you can. All right. Okay, assumptions. So assumptions are always a little bit tricky. So in here it says list those things that may be considered negligible, but and that we're choosing to ignore. Well, we're actually ignoring a lot in this lab. So after you read your Flynn facts describes a lot of other water quality factors. And what you want to consider is did we measure those? And the answer is no, we only measured dissolved oxygen. We didn't measure a whole bunch of other ones. The fact that we didn't measure those is that, could that be important? And how may that affect our decision whether or not your fish could survive in Barker Lake? So the water quality factors are a big one. Think about when you did your testing, do you think that everyone got their water sample from the exact same spot under the exact same conditions? Was the water moving the same conditions? And if not, how could that impact your data? So kind of along with that, probably in your research you want to look into how dissolved oxygen gets into water. And I'll give you a hint, there's 3 different ways. So those are definitely some things we didn't measure that could have an impact. There might be some limitations in your background information which sort of make it tricky to know whether or not your fish could survive. The other thing is, like, when you actually collected your data, do you think that everyone tested it in the exact same way? So yes, we did have all the same Hawk test kits. But think about it, is it possible that while you were really good about not getting an air bubble in your bottle, it's possible that other groups weren't so careful about that, or they just weren't able to? So could that impact your data? And if so, later on in your error analysis, you'll think about that. Okay, so those are some ideas for assumptions. You might come up with some on your own that I haven't mentioned, which is great. Okay, now keep in mind that your assumptions are really going to lead, the next step in your assumptions are your error analysis, which we're going to mention a little bit later on. Hopefully your hypothesis was already done prior to going out to Salt Creek and Barker Lake, whether or not you thought that that your fish could survive. Again, listing the independent dependent variable, we didn't really have one. You could say that as far as your independent variable, that we chose the test site. So we chose where to test the water, and I guess when as well. So you could say that your dissolved oxygen levels would be your dependent variable. Control variables, what was kept the same within a class or groups or things like that. Okay, and we did not have a control group in this lab. All right. So if you're looking at the hypothesis template, it's sort of very involved and structured. I think in this one, basically you would just want to say, I think that, and then put your name of your fish in there, that they could or could not survive because, and you can refer to things in your background information. You can refer to just anecdotal things that you've noticed, like if you notice a lot of trash in there, or if you have some other knowledge that you found out, prior to doing the lab, that's great. The thing you absolutely should not do, you should not refer to the data that was collected. So in theory, the hypothesis was done before we collected our data, and you were making your guesses based on that. Okay, hypothesis is always done before you collect your data, and it's your best guess at that time. Okay, so your hypothesis should include some reasoning in there. Okay. Procedure. As far as your materials list, which you definitely want to include is your Hach test kits. That's HACH. And then within that, maybe you want to list the chemicals that are in there, and maybe the bottles and things like that. Okay, a quick internet search will get you the the exact things if you want. But list your Hach dissolved oxygen test kit. As far as your storyboard or diagram, a couple options for you. If you took pictures of how you were doing the test, along the way, you can include those. You could also you could draw a storyboard. You know, first you get your water, second you added your packets 1 and 2, you know, things like that. So you could draw it out. Another option is to actually show a picture of the Hawk test kit for dissolved oxygen. That's a really good option for you because that's going to show what everything looked like in there. So if somebody wanted to, the idea behind this is that if somebody wanted to carry out our exact same experiment, because maybe they wanted to verify our data, they would have the exact same test kit that we had with the exact same chemicals in it and everything like that. Okay. Your procedure is basically the same one that's in your packet, so just go ahead and type that out again. I would not abbreviate anything, just type it out as is. Okay. Your data table, do not include just the picture of the data table that's in there. What you want to do is you want to put that data table, you know, retype that up into an organized way. What I think would be helpful would have not only your class data in there. I would separate it, you know, maybe you have your all your Salt Creek data next to each other and all your Barker Lake next to each other. And then at the bottom of each of those columns, you should put an average, okay, a class average for that. If you chose not to include some values that were really high or really low, like outliers in that data, then make a note of that when in your calculation. Okay. Your data analysis. Okay, we're going to graph our data, and what I've done on our YouTube channel, RMHS Chem, is I have videotaped one of the ways that you can do this. I think I was doing this in Excel. In Google Sheets, it's very, very similar. At some point later, I might be able to record another video, but I don't have that right now. So if you go to YouTube and you search RMHS Chem, you can click on the channel here, and then you'll be able to find it within there. But if you scroll down a little bit, it says Graphing Dissolved Oxygen Barker Lake Report. And if you watch this, you enter things correctly, I think you're going to have a lot of success. It's about a little 5-minute video. Okay, so we definitely want to graph our data. This is mentioned in the report or in the video here, but it's also good to remember that Excel and possibly Sheets, they may call the bar graph something a little bit different. You want your bar graph to have bars that go up and down, not side to side. So Excel actually calls it a column graph. All right. So we're going to include our graph there. Make sure we label all the axes and things like that. When you do your graph, this graph should be of your averages. I do not want to see 10 different results for site number 1 and 10 for site 2. Show your averages there, and also what you want to have next to the class average, your data. It'll be interesting to see if your data is similar or very different from the class average. Okay. If there was a site you didn't get to, then just don't include that still have your class average, just don't include yours. Sample calculations for this lab are very, very simple. Okay. When you added your drops of your sodium thiosulfate, each drop represented 1 part per million of dissolved oxygen. So what you just want to say as far as your sample calculation, you would say 1 ppm, 1 drop equals 1 ppm, and then if for site number 3 you added 8 drops, you'd say 8 drops equals 8 ppm. That's it. Other test kits, now that seems very straightforward, and why would I even need to include that? Well, the difference is that some test kits, 1 drop equals a different number of parts per million, so there would be more of a calculation involved. So go ahead and include that. If you don't, it's going to knock you back quite a bit on your lab report. Your data summary is you're going to talk about the relationships in your data. Okay, you're going to talk about patterns. Patterns are things that are repeated in your data. Trends are when something is increasing or decreasing. you're not really going to make any conclusions at this point. So it says here, no conclusions. All right, we're just saying this is my data. These are some things that I noticed. Okay, these are some things I noticed that repeated. These are some things I noticed that either increased or decreased. You also want to have like your range of data. Okay, so your high and your low values within there. And so what that really speaks to is the precision of your data. If you have, for a particular site, that on the low end you have someone got 4 ppm and someone got 13 ppm, that's a really big range. So maybe something was off a little bit, maybe about how they tested it or the particular water sample that they took. Okay. So besides all that, what you're going to quickly do in 2 or 3 sentences max is just restate what you were doing in the lab and then how you did it. Okay, we were testing for dissolved oxygen and we were using a Hawk test kit to figure out the dissolved oxygen levels to see if our fish can survive. Okay, restate a little bit what you can as far as what we were measuring, which is our dependent variable was dissolved oxygen. Again, we didn't really have an independent variable. Control variables, everyone tested on the same days, and we also used the same test kits. Okay, once you do that, then you're going to get into like the range of data, discrepancies, like if you had an outlier, like everyone was getting like pH, or everyone was getting dissolved oxygen levels of 8 or 9, and one group was getting like 30. And that's a discrepancy. Okay. Okay. Your error analysis. What you want to do is you want to go back to your assumptions. If you were assuming certain things, they're going to have an impact on your data. Okay, so that's what you want to keep in mind. Now, when you do your error analysis, I think this is the best way and the easiest way of doing it. It also makes it easier for your teacher to grade this because oftentimes you leave out certain things. So if you go back to your Schoology page, we go to the error analysis, and let's open that up. Do yourself and do me a favor, copy this data table into your report. This says it talks about your error, whether it's systematic or random. You can read up on systematic or random here. How the error affects your data specifically. Don't say it's going to change it. I know it's going to change it. It's an error. It will change it. Tell me if it's going to make my value too big or too small. Okay? As long as you try to make a guess about whether it's going to be too big or too small, that's going to be fine. If you're not thinking about it the right way, we'll just make a note, but that's the important thing, is to think about how your data will affect it, your error will affect it. So if you got an air bubble in your bottle, okay, would that make your results higher or lower than they should be? And then think about a way that we should try to help minimize that. Okay, so we're looking for at least 2 errors. Okay, in here, do not say I spilled stuff. And what would I do? Not spill it. Okay, that's not really yes, it's a source of error, but if that happened, you should have just redone your experiment, since you knew you did something wrong or something was spilled. That's not really an error that is going to give you some insight about how the lab has some faults to it. Okay, these sources of error here they can either be systematic, which is sort of inherent into the design of the experiment, or something that just can't be helped with as far as the precision. Okay, so if you have trouble on that, let me know, but I think your assumptions really are going to help you and lead back to your sources of error. All right. The conclusion is a big part of your lab. It's 6 out of our 50 points. And the truth is that at this point, you're almost done with it. All you need to do is copy and paste information from things that you've already done. Okay? The only thing that you really have to comment on that's new is whether you thought that you're going to accept or reject your hypothesis. That's the only thing that's really new. Okay, you're gonna remind me what in paragraph 1, you're gonna remind me about what the lab was about. In paragraph 2, you're gonna tell me what your hypothesis was, and you're gonna accept or reject it. You're gonna refer back to data that you already summarized in your data analysis section. In paragraph 3, you're going to talk about assumptions and errors. Okay. In paragraph 4, again in the error analysis, you've already done this. You've already talked about these are things I think were some errors, and this is how they would affect your data. So you're literally copying and pasting. Okay. And then at this point, discuss what you would do if given for further study. So what would you do now? So you know that there were things that we didn't measure. You know that that there were some errors possibly in this lab. You know that there was ways that we could expand this lab and make it better based on time of year, things that we didn't measure. Maybe we want to do this for other bodies of water in the Rolling Meadows area. Maybe we could investigate if this would be better for a different kind of fish. Okay. Those are all different ideas there. So once you get to the conclusion, okay, finish strong, okay? Recognize that you've done 95% of your conclusion you've already done. All you need to do is copy and paste information that you already have done, okay? So I hope this video helps. I know it was kind of long, but if you are picking up what I'm throwing down in this video, you're going to have great success on your first lab report. Thanks for watching, and thanks for subscribing to RMHS Chem.